Section 2.2 on operations with fractions. We're going to look at several different operations with fractions in this section. The first one is converting a mixed number to an improper fraction. As you can see from the steps listed above, what we're going to start with is multiplying 7 times 5, 35, plus 3. So I'll start with 35 plus 3 as the new numerator over 5, the original denominator, or 38/5 for the improper fraction. Okay, when I want to convert an improper fraction to a mixed number, we're going to use long division. We're going to divide the denominator into the numerator, 9 into 76. 9 goes into 76 8 times. 8 times 9 is 72. So if you subtract, you have a remainder of 4. It goes in 8 whole times with 4 left over. So this is going to be the mixed number 8 and 4/9. Alright, and again, it's just a quick review, so if you want to read more about it, you can look through the book or look at the instructions I'm skimming through. Simplifying a fraction. So this is also known as reducing a fraction. So when I reduce a fraction, I want to divide both numerator and denominator by a common factor. So 42 and 15, let's start by dividing them both by 3. Make sure you divide both the numerator and the denominator by the same number. 42 divided by 3 is 14. 15 divided by 3 is 5, 14/5. Don't forget to check to see if there's another number that can be divided into both of these, but there is not in this case. So I want to make sure I check to make sure that it is in complete lowest terms before I leave it as my final answer. Part B, let's divide these both by 5 to reduce. 5 goes into 35 and 5 goes into 50. So it'll be 7/10. And check again to see if there's a number that will go into both 7 and 10. If not, consider it reduced. When I multiply two fractions, I want to multiply the numerators and the denominators, reducing first if possible. For example, I can see that the top 14 and the bottom number 21 will be divided by 7. When I multiply these together, it's going to create a large number that can also be divided by 7, another large number that can also be divided by 7. So it's easier for us to do the multiplication if we can divide that 7 out first. 7 goes into 14 twice. 7 goes into 21 3 times. Now consider the 10 and the 8. They can both be divided by 2. 2 goes into 10 5 times. 2 goes into 8 4 times. And one more cancellation here. Any numerator with any denominator, 2 and 4 can both be divided by 2. So I should use a different color. 2 goes into 2 once. 2 goes into 4 twice. Multiply anything that's left for your final answer. So my final answer is going to be 1 times 5 is 5 across the top, and 2 times 3 is 6 across the bottom for 5/6. Alright, let's check out Part B. Part B is a set of mixed numbers. Mixed numbers cannot be multiplied. They have to first be turned into improper fractions. So let's make these improper. So 3 times 4 is 12, plus 3 is 15/4, multiplied by 1 times 5 is 5, plus 3 is 8/5. I must make them improper before starting to reduce. When I reduce, I can notice that 5 goes into 15 3 times, and 5 goes into 5 once, 4 goes into 4 once, 4 goes into 8 twice. So we're left with 3 times 2 is 6 over 1. 6 over 1 is improper, so let's rewrite that as 6. 1 goes into 6 6 times. Next is division. We know that to divide two fractions, we're going to flip the fractions and multiply. So my two fractions right here will become 45/16. If I'm dividing by 35/8, that's the same as multiplying by 8/35. Now follow the rules for multiplication. 45 and 35 can both be divided by 5. That'll give us 9 and 7. 16 and 8 can both be divided by 8. They'll give us 2 and 1. Finish the multiplication. 9 times 1 is 9. 2 times 7 is 14. 9/14. Right? Again, you cannot multiply or divide a mixed number. These must be turned into improper fractions. So, my improper fractions will be 30 plus 3 is 33/5 divided by 1 times 10 is 10 plus 1 is 11/10. Then change that division into a multiplication. So 33/5 times the reciprocal times 10/11. Let's reduce. 11 goes into 33 3 times and into 11 once. 5 goes into 5 once and into 10 twice. So the answer to this is 6/1 or 6. 6/1 is not considered simplified. You must reduce your final answer to 6. Alright, addition and subtraction. You can add and subtract improper or mixed numbers, but they have to have the same denominator. If they don't have the same denominator, we need to figure out what to multiply each fraction by to create a common denominator. So 5/6 plus 3/8. 6 and 8 will both go into 24. So I'm going to be working with the LCD goal right here of 24. To get my common denominator to be 24, 6 needs to be multiplied by 4, so I'll multiply both top and bottom of its fraction by 4. 8 needs to be multiplied by 3, so multiply both top and bottom of its fraction by 3. That changes our fractions to 20 24ths plus 9 24ths, or 29 24ths. Check to see if this fraction can be reduced. It is an improper fraction, so it could be changed into a mixed number, but it cannot be reduced. There is no number that divides into both of these, so it is perfect as it is, cannot be reduced. Fractions do not need to be turned into mixed numbers, just reduced. Okay, part B, 7/15 minus 3/10. The common denominator here, a number that both 15 and 10 will go into, is 30. So we want to make both of these fractions have a denominator of 30. To make it a 30, the 15 needs to be multiplied by 2, so the 7 also needs to be multiplied by 2. 10 needs to be multiplied by 3, so its numerator also needs to be multiplied by 3. That will give us the fraction 14 30ths minus 9 30ths. 14 30ths minus 9 30ths is 5 30ths. 5 30ths can be reduced. Divide both by 5. You'll get 1/6. So the final answer is 1/6. Alright, on the next page we have an expression to evaluate. Values for x, w, y, and z are given. So if, let's see, w is 9, we have a 9 in the denominator, x is 2 in the numerator, y is 11, and z is 45. So plug all the values in, and now it's a division problem, so we're going to flip the second fraction and multiply. So this becomes 2/9 times 45/11. We check to see if there's any reducing to do during multiplication. 9 goes into 9 once and into 45 5 times. 2 doesn't go into 1 or into 11, so we can't reduce there. So we have 10/11, and that's simplified. So 10/11 is my final answer. Alright. Example 8. Translate from the English to an arithmetic or an algebraic expression. A number decreased by 1/4 of itself. So a number, it's going to be our x, decreased by, we're taking this quantity away from this one, so subtract 1/4, the fraction 1/4 of, that's a word that is used in multiplication when there's a fraction involved, so of itself, which is the number again. I don't need to write this symbol. the symbol being the multiplication symbol between a number and a variable. So I can simply write x minus 1/4 x. And I believe this is our last example. Yep. The temperature of a cool fall day is 68 degrees Fahrenheit. Use the formula to find the equivalent temperature in degrees Celsius. Okay. My temperature here is in degrees Fahrenheit, so I'm going to plug that in for the F in the equation to find the answer in degrees Celsius. So C equals 5/9 times 68 minus 32. This is just an equation that happens to contain a fraction, so we're going to simplify. Parentheses first, then we'll deal with our fraction multiplication. So we have 5/9 times 68 minus 32 is 36. Now, to do the multiplication, we'll think about this as being 36 over 1 and reducing our fraction. 9 goes into 9 once, into 36 4 times, so the answer is going to be 5 times 4 is 20. It would have been 20 over 1, but 20 over 1 is the same thing as 20. And don't forget to put those units, degrees Celsius, back on your final answer.